In this video, we'll go over how to identify where a function is increasing, decreasing, or constant using graphs and equations. This concept will help you understand how functions behave over intervals. So let's get into it. Let's start by going over the formal definitions. A function on the interval I with x1 less than x2 is increasing if the y values are also increasing. So f of x1 is less than f of x2. Now the function is decreasing if the x values are increasing and the y values are decreasing. So f of x1 is greater than f of x2. Now the function is constant if the y values are the same. So f of x1 equals f of x2. These definitions will make more sense once we do some examples. When we describe increasing, decreasing, and constant behavior, we're going to be using interval notation, which I've made a separate video on. But I want to clarify that it is also based on the x values only. So we're only using the x values when doing our intervals. Here is a graph-based example. It is a piecewise graph, and let's find where the function is increasing, constant, or decreasing. If you remember our definitions, we know that as the x values get bigger, if the y values get bigger also, so as the x values increase, if the y values increase, we're increasing. And we can see that as these x values get bigger, our y values get bigger. We're going up. And so this interval right here will be increasing from -4 to -1. So we know we are increasing on the interval -4 to -1. Again, we are using the x values. Now, we know that if the x values are getting larger, but our y values are staying the same, we are constant. And that is happening right here. We can see that our x values continue to get larger, but we're staying the same. We're staying on the same y level. So we are constant on the interval -1 to 1. Now, we can see from 1 to 4, our x values are getting larger, they are increasing, but our y value is decreasing. So this is decreasing from 1 to 4. So our decreasing interval will be 1, 4. And that is how you would determine a function's behavior via a graph. Now there's a few key points that we need to remember. 1, we move left to right. 2, we look at the graph's shape. What y is doing as x increases. And in 3, we describe the intervals using x values. Now let's do an algebraic example. So let's say we're given the function f of x equals x squared minus 6x plus 5. We know this is a parabola opening upward, so the vertex will tell us where it switches from decreasing to increasing. So to find this interval, we will first find the vertex, which we could find by x equals negative b over 2a, which in our case is negative 3 over 2 times 1, which equals 3. So we know the function is decreasing from negative infinity to 3 and increasing from 3 to infinity, which we can see in our graph. All right, now let's get some practice. Pause the video and write down where it's increasing, decreasing, and constant. So starting from the left, we can see that our x values are getting larger, but our y values are decreasing. So from negative 6 right here, all the way to negative 2, we know we are decreasing. So we're decreasing on the interval negative 6 to negative 2. Then we can see that from negative 2 to 1, our x values are increasing, but our y values are staying the same. So from negative 2 to 1, we are constant. And then finally, working left to right, we can see that from 1 to 5, our x values are increasing and so are our y values. So from right here at 1 to 5, we are increasing. On the interval 1, 5. That was a quick video on increasing, decreasing, and constant intervals. If this helped, give it a like to support the channel and subscribe for more straightforward math videos. Thank you for watching.